This is the intro video for Algebra 1, Section 5.2, and we're going to be looking briefly at zero and negative exponents. So we're going to start off with our rule. Our rule for zero exponents is this right here, x to the zero, so that means any base, with one exception, but any base to the zero is going to end up giving you 1. The one exception to this is you can't have 0 to the 0, and we'll talk about that exception in class. But for now, let's just say that any base with an exponent of 0 is going to equal 1. So, based on that, if you would take just a second, pause the video, and try numbers 1, 2, and 3, we'll compare answers here in a second. Okay, so for number 1, 30 to the 0, let's be careful to identify our base. Our base is 30, and our exponent is 0. And let's remember that with that one exception, any base with an exponent of 0 is going to give you a result of 1. And so the answer to this one is 1. Let's take a look at number 2. Let's identify the base. So for number 2, the base is 5y. And of course, you can see an exponent of 0. So once again, we follow that rule. Any base with an exponent of 0, with the one exception, is going to give you 1. So this will end up equaling 1. Number 3 is where it gets a little bit tricky. The trick here is to correctly identify the base. The temptation is going to be to say that the base is 5y, but the base is not 5y. The base is just y. The parentheses in number 2 group the 5 and the y together as a base, but in number 3, the base is simply the y. So what we would do with this is we would say that you could maybe break it apart and say it's really 5 times y to the 0. And then here, the base being y, the exponent being 0. Any base to the 0 is 1. And so we end up with 5 times 1. So this one would end up equaling 5 for a final evaluation. Let's also take a look at our other topic in this section, and that is negative exponents. So you can see that we've got x to the negative n right there. What a negative exponent means is that we need to take the base and we need to flip it to the other level. And by the other level, I mean, I'm talking about numerators and denominators. So a base is either in the numerator or in the denominator. It's not in both, or it's not in either. It's one of the two. Right now, as this one is currently written, the x is in the numerator, right? Because we can always write any base over 1, and it does not change the value. So with the negative exponent here, it means to take this base, which is currently in the numerator, and flip it to the other level. So it'd be flipped to the denominator. So I'll write that fraction bar again. The x gets flipped down. The exponent is no longer negative because we've flipped it down. We've done what it asked us to do. And we've got a blank numerator. Anytime you get a blank numerator, or denominator for that matter, you can fill it with a 1. Okay, so armed with that knowledge, I would encourage you to pause the video, try numbers 4, 5, and 6. Push play when you're ready to see the solutions. Okay, number 4. In number 4, the base is 10, and the exponent is negative 2. And so a negative exponent means to take that base, flip it to the other level. So right now, this 10 to the negative 2 is currently in the numerator, so I'm going to flip it down to the denominator. So this would give me, in the denominator, 10 to the positive 2. Again, it's positive 2 because I've done what that negative exponent asked me to do. I've got a blank numerator. Anytime I got a blank numerator, I'm going to fill that in with a 1. And then my final step here would be to do 10 squared. 10 squared is 100, of course, and so I end up with 1 over 100, or 1/100th. Okay, number 5, a to the negative 12. Really similar situation. The a is in the numerator, so I could write it over 1. And I want to recognize that a is the base, and negative 12 is the exponent. So anytime I've got a negative exponent, that tells me to flip the base to the other level. And so since the base is currently in the numerator, I'm going to flip it to the denominator. So it's going to become a to the 12. And again, like before, I've got a blank numerator. So anytime I get a blank numerator, I'm going to fill it in with a 1. And in this case, there's really nothing I can do with a to the 12th. I can't do anything further with that. And so 1 over a to the 12th would be my answer. And then finally, number 6, we want to be super careful with number 6. I want to be really careful about correctly identifying bases and exponents, numerators and denominators. So as it stands right now, this negative 2 is the base, and the -5 is the exponent, and the -2 base is in the numerator right now. So that -5 exponent tells us that we need to flip the base to the other level. We want to be really careful with this. So what I'm going to do is draw my fraction bar, and I'm going to take that whole base, which is -2, and I'm going to write it in the denominator, and now the exponent is a +5. Again, because I've done what it asked me to do. Now that I've done that, I need to recognize my numerator is blank. I'm going to just leave it as or I'm going to write it in as a 1. And finally, what I need to do is evaluate -2 to the 5th power. So if you remember from before, -2 to the 5th power means -2 times itself 5 times. You could do this on a calculator. You could do this out by hand. I think you'll find that -2 in parentheses to the 5th power is going to end up being -32. And so we end up with -1/32 for our final answer on number 6. Of course, there's a lot more we can do with this, and when I see you in class next time, we'll do just that. I'll see you then.